Hello and welcome back to Izzo Math. Today we're going to be talking about radians, and what always comes to fruition is essentially what is a radian. Well, we have two different methods to measure angles. Obviously, we have the degrees, which we all know that 360 degrees are in a circle. But we can also use mathematicians typically use what is a radian, and a radian is nothing more than the radius, an angle made by taking the radius and wrapping it along the edge of the circle. So, for instance, if I have this radius right here on the unit circle, which obviously this length here has 1, if I take that radius of 1 and wrap this thing around the unit circle, it'll cut out an angle. This is equivalent to 1. This will cut out a new angle. And that angle actually has a measure of 1 radian. Symbolizes 1 rad. To give you a better idea, let's take a look at this graphic. So if I take any circle here and try to find out what a radian is equal to, remember the angle made by taking the radius and wrapping it along the edge of the circle will cut out a radian. So here I take the radius and I wrap that length around the circle, and that creates a unit of 1 radian. So any circle, you take its radius and you wrap that around the circumference of the circle, the angle that's cut out is equivalent to 1 radian. Now the question is, how many degrees are in a radian? Well, let's try to figure that one out. I know that going around half the circle is 180 degrees. So in terms of going all around, I approximately can get approximately 3.14 radians around the circle, which we obviously know is pi. So half a rotation around the circle is 180 degrees, which is equivalent to pi radians. Furthermore, a radian, we know that a radian now cuts out a length of the circle's circumference equal to its radius. And to go all the way around a circle, or any circle, there are 2 pi radians in a full circle, no matter what the size of the circle is. In other words, if you cut pieces of string exactly the length from the center of the circle to its edge, and wrap it around the circle, piece them all together around the circle, you're going to go around exactly 2 pi times, or roughly 6.28. And we now know that since a rotation around the entire circle is 2 pi radians, right here 2 pi radians, we also know that in degrees the rotation around the entire circle is 360 degrees. Therefore we can conclude that the angle measure of 2 pi radians is equivalent to 360 degrees. And we can utilize this to help us find conversion and formulas. This also is commonly written, obviously, as pi radians is equivalent to 180 degrees, just dividing both sides by 2. So that's what you're going to see. Now let's try to see if this works out intuitively. If we come here and we figured out from our previous unit, if we want to know this arc length from that corresponds to a 90-degree angle, we know in our previous example that we figured out this arc length to be pi over 2. And again, the reason we said that is essentially we concluded in our previous lesson that all the way around the circle has a circumference of 2 pi. A quarter way around the circle would equal half pi. Well, what we're saying in radians now is not only is this arc length half pi, but its radiant measure, its radiant angle measure is also half pi. And that kind of touches base, or gives a little glimpse of the advantage of using radians. Essentially, the arc length and the angle measure in radians are equivalent. So if I have an angle measure of half pi radians, it also means that my arc length in the unit circle has a value of half pi. So that is the one to touch base a little bit of the convenience of using radians. Now here are some examples of converting from radians to degrees. In this example, we're asked to convert 7 pi over 90 rads into degrees. Well, we know that theta radians is equivalent to theta times 180 degrees over pi. Now, take a look at that real quick. 180 degrees over pi is a unit fraction equivalent, meaning 180 degrees is equivalent to pi. It's nothing more than a fancy conversion fraction from degrees to radians. It has essentially a value of 1, meaning 180 degrees around the circle is equivalent to pi radians around the circle. So they have equivalent measures. So that is nothing more than fancy formula 1. We're looking for the value of 7 pi over 90 rads. And essentially what we're doing is, well, my theta value here is 7 pi over 90, and my conversion fraction is 180 degrees over pi, which is nothing more than a fancy formula 1. Now before multiply, I know I can cancel out my pi's, and I know that this guy and this guy will reduce to 2, so I'm left with simply 7 times 2 degrees, which comes out to being 14 degrees. So that means that 7 pi over 90 rads is equivalent to 14 degrees. So remember, the trick here is your conversion fraction. This is nothing more than a conversion fraction. Now in this example, I'm asked to convert 10 degrees to radians. Well, what I'm going to use for this is my formula. Essentially, I still have my unit fraction there, but you notice now my unit fraction is radians over degrees. So pi radians is equivalent to 180 degrees. So to convert 10 degrees into radians, I simply am going to take my degrees, my 10, and multiply it by 180, my conversion fraction. And what happens with this guy is ends up being 10 pi over 180, which obviously reduces down to nothing more than pi over 18. And that's my rads, carrying my rads all the way down. So 10 degrees has an equivalent measure of pi over 18 radians. Now let's find the radians of some common special angles. Remember, the special angles are pretty much 90 degrees, 45 degrees, 60 degrees, 30 degrees, 180 degrees, and sometimes 360 degrees or 0 degrees. But let's first go back. 90 degrees we did earlier. We know that the arc length of the 90 degree is essentially pi over 2. So we know that the radian measure of 90 degrees is equivalent to pi over 2. Question is now, how do we find out the radian measure of a 45 degree angle? That 45 degree angle. Yes, we can go through the formula that we just used, or we can also use the intuitive notion that 45 degree angles cuts this arc length in half. And if the arc length of the 90 degree mark is half pi, we essentially need to take half of half pi. And through mathematics, if we take half of half pi, that essentially comes out to being pi over 4, or 1/4 pi. Which also makes sense, because remember, the arc length is going around the entire 2 pi circle. This distance from here to here is equivalent to 1/4 of 2 pi all the way going around. Or, I'm sorry, 1/8 of 2 pi going all the way around. Now let's think about the arc length of 180 degrees. We know that 180 degrees corresponds to halfway around the circle. Well, we also know that the arc length around the entire circle is 2 pi. Therefore, the arc length around half the circle has to be equivalent to pi. And since the arc length in radians is equivalent to the angle measure in radians, a degree measure of 180 degrees is equivalent to pi radians. And again, you can include the radians here. RAD is for abbreviation, but it's also, if you leave it blank, it's also implied that it is in radians because it is a natural measurement. Now the question is, how do we find 60 degrees? Well, we can use some common sense here. We know that this is roughly 60 degrees, and we want to find out that arc length right here. Well, if I go around halfway around the circle, I've traveled 180 degrees, but I'm interested in 60 degrees. Well, 60 degrees is simply 1/3 of the distance to halfway around the circle, or essentially 1/3 of 180 degrees. So utilizing that concept as well as we did before, 60 degrees is equivalent to pi, the 180 degrees, divided by 3, because it's 1/3 of the distance. Therefore, 60 degrees has an arc length, or a radiant measure, of pi over 3. And similarly, we can also do the same thing with 30 degrees. We can either take our 60 degrees and cut that value in half, or we can also know that 30 degrees goes around half the circle, or into 180 degrees 6 times. So this guy, 30 degrees, is going to be 1/6 of 180 degrees, or equivalent 1/2 of the 60 degree measure, which comes out to being pi over 6. And these are the angles that we need to make sure that we're comfortable with. These are called our special angles, and we need to know these radians like the back of our hand. Hope everything's going well, and remember, stop by to Isomath for all your math needs, and we'll see you soon.